Hey there, my name's Ryan. I wanted to take a shot at making a little video to help visually explain object-oriented programming in JavaScript. It can get confusing pretty quickly, and especially with newer syntaxes for creating objects in JavaScript, it can mask JavaScript's prototypal nature and what's actually happening under the hood. But I think if you can get a good visual mental model for what's actually happening, then you can look at any syntax that someone's using and understand what's really happening under the hood and debug that situation. So let's just look at a simple example. First, I've just created an object here that has a property monkey that has a value of the string yep in it. So just some sanity checks. Is this object that I've created, is it an object? Yes, it is. Is it a function? No, it's not. Does object have its own property called monkey? Indeed it does. Does it have its own property called elephant? No, it does not. But that's really interesting already, and we're going to see why. So I'm calling, so first of all, I'm looking for a property called elephant here on obj, which we know doesn't exist. It only has monkey, but I'm getting a value back of false. But why am I able to call has own property in the first place on object? Has own property is itself, you can see dot notation here. I am trying to reference a property called has own property on object, on obj. There's no has own property here, right? It's just monkey. So how am I referencing this property and then trying to invoke it as a function and pass it an argument? How's this happening? Let's take a look. So here's a visual representation of what's going on here. This is obj. It's just an object, right? It has our monkey property, which has a value of yep. And there's a couple other properties that all objects, all of them in JavaScript get automatically. A dunder proto property and a constructor property. Okay. The dunder proto property is what JavaScript uses to keep looking up the hierarchical chain, up the prototypal chain, for properties that it doesn't find in the object that we're currently looking at. We can see here that obj dunder proto property refers to something called object, and specifically the prototype property on it. Well, object is nothing more than actually a function. But all functions in JavaScript are actually function object. Well, they're all functions in JavaScript are actually also objects. So you can think of them, so it's a function, but you can think of them as having an object form as well. Okay. All object forms of function object combinations in JavaScript have their own hidden property called prototype. Prototype, the property, actually refers to another object. Okay. In this situation, objects, a function object combination, its prototype property refers to another object, and this is where all of that functionality that JavaScript gives us that's meant to be for objects that we have, that all these objects can inherit from and get this behavior, this is where it sits. So you can see if I were to go into the console and look at that property on object, you would see I have constructor, has own property. Oh, there it is. So that's how JavaScript found has own property. When we call it, when we look for has own property on object, there is no has own property here. It's not here. There's just monkey. But because JavaScript its prototypal nature, it's the way it works. It doesn't quit looking for has own property, so it looks by default. This is just the way the rules are set. It looks in dunder proto, So Dunderproto's property references object.property. And so it goes over here, finds has own property, and is able to call that function, pass in that argument that we gave it. Now, what's the constructor hidden property? In this case, it points to the function object combination itself, right? It points to object. And that seems kind of strange that this thing called object is actually a function. But it is indeed true. You can see here, type of object is a function. Okay. I also included these 2 lines of code here so that we can see that our understanding of what is happening on the visual diagram is in fact true. Objects, Dunderproto, right here, does in fact point to the prototype property on the on object, which is a function object. You can think of it as a function object combination visually. Now, this is deprecated, this way of looking at the Dunderproto property. It's recommended that you use object get prototype of obj. It does the exact same thing. So yes, it's also true. It points to object.prototype. If you're curious about that, you can look at the documentation here. Okay, I still like using Dunderproto because that is it is there, and I think it's just less wordy and easier to use for illustration purposes. So I think that concludes our first example. Things are going to keep getting more interesting, and they'll kind of get more complicated before they get easier, and we start looking at code that we would actually write to create different objects in JavaScript. I forgot to mention one other thing with example 1 here. So I just have a bit of code here that says I reference obj, and I try to reference its constructor property, right? And test what in fact it does refer to. It refers to object, like we discussed. And not the prototype property on object, it refers to object itself, right? As opposed to Dunderproto right here, which refers to object.prototype, the prototype property on object, right? So this brings up an interesting question maybe, but it's really important to get this straight and differentiate this. What is the prototype property on object referring to? Right here. Is there a prototype property here on object? No, there's not. Okay. There's certain built-in properties that JavaScript will put on any object. Dunderproto is one of them, constructors another one, okay? It does not give you a prototype property by default on objects, plain old objects, okay? Doesn't happen. So if you try to reference this here, you get undefined. Undefined. However, on the object form of function object combinations, that is the situation in which you always get a prototype property given to you. And by default, you know, here we're looking specifically at object, which is a function, you know, that JavaScript gives us built in. But if you were to create your own function in JavaScript, just a plain function that did nothing, right? It would have an object form. It would have a prototype property in it, and it would refer to just a empty object. And we'll get into why that's really, really important for object-oriented programming, because that is going to be the place that JavaScript lets us put all sorts of functionality that we want objects down the prototypal chain to inherit from. So already you can start to see how this is a bit confusing. And specifically, part of the problem is that JavaScript has chosen some language that makes it really confusing. So An object's prototype is said to be the next link up in the chain, so the object that the current object inherits from, right? So what's objects, in common parlance, what is object's prototype? Well, it's the prototype property on object. It's this thing right here. But really, when we're talking about what an object's prototype is, we're talking about really what is dunder proto pointing to. It's pointing to this, right? Well, now JavaScript has already gone ahead and named this property that it built-in gives you on function object combinations. It also named that prototype. So that gets a bit confusing, right? That they say that prototype's also the name for that specific property on the object form of functions. This is where a source of a lot of confusion comes from. What's the difference between dunder proto and what's the difference between prototype? Well, dunder proto is a hidden property that's given on all objects, and it just tells JavaScript where to look up the chain for additional functionality. Prototype, and that next thing up the chain, is called this object's prototype, unfortunately. Okay. Prototype is a hidden property on all function object combinations, but not objects. That refers to itself another object. That's the difference. That's the source of the confusion there, and it's unfortunate, but it is what it is. And just real quick, I forgot I didn't explain what the constructor property really is. It refers to object here. But if we pull up the docs, we can see that the constructor property returns a reference to the object constructor function that created the instance object. So in other words, it refers to the function that created the object that we're looking at. So we're looking at this here, this object. Well, what created it? Well, let's look at the constructor property. Object did. Okay, let's look at example 2. This is really short. Last time we started with a basic object. Let's start with a function that I create here called func. And this function doesn't do anything because it's just not really important for right now. But you know that I can call function with the property call, right? We all know that you can call functions with call, and that allows you to specify a context and then pass remaining arguments, right? I assume that's just requisite knowledge here for this video. If you are somehow stumbling across this video and there's some things you don't understand that are just table stakes, then this video is not quite for you. You need to understand some of these other things first, some of these other fundamentals. But anyways, you all know that we can call function with call and specify a context. But why? Again, just like the first example, what I'm actually trying to do here is find a property with the name of call and then invoke it as a function, right? I'm trying to utilize method invocation here on func. So what's actually happening? Just like we talked about in the last example here, here's func. It is a function, but we know that all functions in JavaScript are also objects, and so we can visually think about them and look at this object form. And we know that, remember, every function object combination has that property prototype, right? Not regular old objects, they're not given this by default, but all functions are. Okay, and in this situation, this example, I just want to show that it's here, but it's just not applicable. It's just an empty object, right? And again, that's going to become very useful when we start writing our own object-oriented code. This is going to be the place where we're able to store functionality that we want things to inherit from. Okay, But for right now, it's just an empty object. It's sitting there. It's of no use to us in this example. We know that because all functions are objects, right? And so we can look at this object form here. Well, it is an object, so right, it has and all objects have a dunder-proto property and a constructor property. So this function, this function called func, has a dunder-proto property that refers to the prototype property on something called function. Function is just like object that we looked at in the last example. It's a function itself, which is also an object, so it has this object form. It has a prototype property on it that refers to another object. And in here, this is where JavaScript stores all of that functionality that's specific for functions to inherit from, like call, right? In the last example, we were looking at the prototype property on something called object, which was a function as well. But that prototype property had an object full of all the functionality that was specific for objects to be able to look up to. This one is an object that contains all the functionality that's that functions that you create can look up to, that are specific to functions and not objects. So this is where things like call are stored. And that's why in our code here, this code will not actually throw an error. Now, it doesn't do anything, right? I haven't specified a context, and func doesn't actually have any functionality to it, but it does run. There's no error. And again, just our code to double check what's actually happening. Is func's dunder-proto property, is it pointing to the prototype property on function, like we say here? Yes, it is. And what does func's constructor property point to? It points to function as a whole. Okay, that's it for example 2. Okay, just one more example like this to drive this home, that this is how JavaScript works, and this is how you get all this built-in functionality. Because when we start writing our own object-oriented code, it's going to work just like this. But this demonstrates that like the way that JavaScript actually works the same way. So here's example 3. This is just an array I've created here, right? And we know, similar to the last example, there's methods I can call on any array, like join, right? Even though join isn't a property that's specifically in this array, yet this works. And why does that work? Let's take a look. So it's very similar to the last example, right? Interestingly, here's array here. It has a couple properties on it, 0 and 1. Interestingly, arrays are objects too in JavaScript. So let's see, right. So type of array object is, right, type of array is an object. So, and it has properties 0, 1, right? And that's why we can reference those properties and get back the values that those properties refer to, right? But arrays are nothing more than objects in JavaScript. So all objects in JavaScript have a dunder-proto property, and they have a constructor property. So when we try to reference a property called join, and then which we're expecting to refer to a function, because then we're going to invoke it with an argument here of an empty string, right? JavaScript, same as the last examples, goes about looking for join. Okay, join is not a property on array. So what does it do? By its nature, it looks in the dunder-proto. It looks at dunder-proto property, which refers to the prototype property on something called array. Just like the last examples, array is something built in. It's a function, but all functions are objects. So we can look at its object form here. And remember, all objects, all functions, sorry, all every object form of a function, right? All functions have that built-in prototype property that refers to another object. And here, this is where JavaScript stores all of that functionality that is meant for any arrays that we create to inherit from. That's why when it looks in the Dunner proto, it looks at this object here that's referred to by the prototype property, and it finds a join property here. Then, we use parentheses to indicate that we're invoking the value that join refers to. Join refers to a function, so we're going to invoke that function. And that's why that works. Now, the constructor property of our array, R here, refers to something called array, which is just this function. Okay, so let's check this though, just to check our understanding real quick. What's the prototype property on array, on this array here, R? It's undefined. Remember that we get certain properties given to us by JavaScript on objects, like proto and constructor, Dunder proto and constructor. We don't get prototype property. Prototype is not a property that we get automatically on regular old objects. It only comes on functions. So that's why if you were to try to reference the prototype property on an array, it would be undefined. Okay, that's it for this example. One other thing I just wanted to show real quick with example 3, if I were to go into the console and look at that array.prototype property here, where I said JavaScript stores all that functionality that's meant specifically for arrays that we use to inherit from, we see all of these things here, and we should find join, and there it is right there. Okay, hey there. I'm about to explain example 4. I did make a mistake, unfortunately, in my picture, in my drawing here. And I don't want to, I'm not able to correct it because I'd have to re-record all the videos after this, and I don't want to do that. So just keep in mind that the properties on R here are 0 and 1. You're going to see that I mistakenly put A and B here. Just had a slip of the mind. So just keep that in mind. In the upcoming diagrams, you're going to see A and B here. They should be 0 and 1. The other thing I just want to clarify is that I'm going to walk through and explain how we're able to invoke a method has-own property on R here. And I do a good job, I think, pretty good job of explaining how we walk up the chain and find it in the prototype property on object here. And once we find has-own property, it refers to a function. And just keep in mind that the way that function is implemented by JavaScript utilizes the this keyword, and I expect that everyone understands how the this keyword works. And that's how we're able to invoke this function that we find in the context of the calling object R. So this is example 4. This is where things start to get a bit hairy. But I promise that, if you stick with it, this is going to make understanding code examples that we actually write, object-oriented code, that we actually write, much easier to understand. And I don't think you necessarily really have to have all of this memorized and know it by heart. But this is really, I'm just showing how JavaScript itself works, because it works just like the code that we're going to write works. So let's look at this example. So here I just have an array with A and B in it. And if I try to log out, if I try to invoke the method has-own property on array and pass an argument of 0, I do get true, right? It's because array is just an object, or R is just an object, because arrays are objects, and it has a property of 0 in it. Let's let's take a look at how that plays out. So here we have our, forget about everything else. Don't look at this yet. We'll get to it. So array is here. We have an object. We have A and B as properties in it. Each of them reference their respective string values here. Since array is just a regular old object, remember here, it has a dunder-proto property and a constructor property. Okay, it's dunder-proto. So if we're looking for has own property, we're looking for a property that has that name, right? And we're trying to reference it in this R. So JavaScript will look, it has A and B, doesn't have has own property, so it looks in the dunder-proto and sees where that refers to. Well, it refers to the prototype property on the array function, right? It's object form here, which that prototype property references another object, right? Which has a bunch of built-in functionality, you know, as we looked at in the last example for arrays, which shows things like join, which references a function here. There's a bunch of things in here, right? In addition to join. I'm just showing that as one example, right? Now, if JavaScript doesn't find it here, well, this is just an object itself. So it therefore also has a dunder-proto property, which references the last link in the chain, which is the prototype property on object, which is itself, again, another object. And that's where we find has own property. We find a property called has own property, and it refers to a function, and we invoke that function here. And that's how we're able to invoke that function, and it works. So here's some code just to double check what's going on in my diagram. Is the dunder-proto property on R, does it actually point to array.prototype? Yes, it does. Let's see. Oh, it's because I got rid of the R. Right. So yes, it does. The dunder-proto property does reference the prototype property on array. Okay, good. Does the constructor property on R reference array itself? Yes, it does. And does, now what about that next link up, right? Array, the prototype property on array, so here, right? Its dunder-proto property, where does it look at? Well, it does look at the prototype property on object right here, just like we discussed. Okay, so now you'll see that the dunder-proto object, the prototype property on object, right, refers to this last place, this last little object. Well, it is still an object, so it does have a dunder-proto property, but it refers to null, nothing, since it's the last link in the chain. Okay, so if you try to reference it, you'll get null here. Right there, I was I made a little mistake in this last example, so I just wanted to correct it here. So what I'm trying to show is that if we try to reference a property on something and JavaScript goes looking up the prototypal chain and it can't find it, you know, you're going to get undefined. So in this situation, we have, you know, we're trying to reference some sort of property called fantastical, right? And it checks an array, it has A and B, doesn't see it, checks in the dunder-proto, which points to the prototype property of array, which itself is an object. It has things like join in here, right? That's and other things that are functions that all arrays in JavaScript can inherit and use, right? It doesn't see anything by the name of fantastical, so it looks, it's, you know, and this object itself, right, is a object, so it has a dunder-proto property. And that points to the prototype property on object, right? Still doesn't see some things in here, right? Things like has own property, right, which is a function. But it doesn't see anything but the name of fantastical. And then so it goes to check in its Dunner proto property, and it finds that that refers to null, because this is the last object in the chain to look at. And so since it doesn't find it, we get undefined here, right? And if we were to, if we were thinking that that was going to be a function, right? And so we were going to call the method here fantastical on array, we'd get an error because we'd be trying to invoke undefined, right? Fantastical is not a function. It's undefined. Okay, so that is why that sort of thing happens. Now, let's look at the rest of this. It's admittedly a bit hairy. I do want to show one thing real quick first, I guess. So this bit of code here, we know that it makes no sense in this context right here, but you know that you can use it when you're working with functions, right? And you pass arguments to a function, and then inside of that function there's a keyword that you can utilize, arguments, right, which represents an array-like object that contains all of the arguments that were passed into that function, right? And this code, what it's doing is we're creating an array from that array-like object, represented by the keyword arguments. Okay, but the intent is not to explain, that functionality really. Okay, this is not the context in which you would use this. I just want to show that we all know that we can write code like this inside of a function, right? And what it will do. But why? Why can we find this property from on this thing array, which is a function? Why can we do that? Well, let's take a look. So on array, which is a function, which is also an object, so it has this object-like form, right? It has a prototype property, a Dunner proto, a constructor, but it also has other properties within it, right? One of them is from, which that property references a function, right? And so that's why when you call from on array like this and pass in an argument of arguments, it works because JavaScript goes here and it actually doesn't have to go up any chains. It finds from right in array here. Okay, so how's the rest of this working? Now this gets into, this gets into how JavaScript works itself. JavaScript itself works just like the object-oriented code we're going to write. It uses its own prototypal nature to retrieve functionality that it creates for us. And I don't think it's important that and have all of this memorized, exactly how this works, but I just want to show that it is in fact how it works. So just a sanity check, are these three things here, array, function, and object, what are they? Array, function, object, they're just functions, right? As I think I showed in some earlier examples. Okay. But all functions are objects, so they have that object form. Let's turn to array real quick and look at its Dunner proto property and its constructor property. Well, its Dunner proto property refers to the prototype property on the function, and its constructor is function itself. Okay. Interesting, and we can confirm that via this code here. True. And then when we look at function and look at its Dunner proto property and its constructor property, what's going on there? Well, interestingly, its Dunner proto property refers to the prototype property on itself, function, and its constructor property refers to itself, function. And if we were to look at object, its Dunner proto property refers back to the prototype property on function, and its constructor refers back to function. So again, a bit hairy. We can confirm that via this code as well. You can play around with this. I think it's important that you have a general idea that this is how all this is happening, and this is how JavaScript is giving you some of that built-in functionality, and this is where it's going and looking for it, and how it's getting it, and how this is all, and how JavaScript itself is working. But I think if you can understand just the general nature of this and how visually this happens, we're gonna have a much easier time understanding our own code, which I think is much simpler actually than this final example here showing how JavaScript itself gets you functionality that's built in. Yeah, so that's all for example 4, and we're going to start looking at some actual object-oriented code that we would write now. Okay, there's one last thing I want to just look at before we actually move on. Let's see what the prototype property in array looks like. What is its type? So we're looking at array, which is a function. All functions are objects. We're looking at this object here, represented by its prototype property, right? Here. And what type of thing is this? Is it an object? Yes, it is. That's expected. And what is the type of thing is the prototype property within object? Right here, the prototype property within the function object. This object here, what is it? It's an object. Yes. This is where things get a little strange. You noticed that object and function have this sort of circularity between them going on. What about here? Function's prototype property, what does it refer to? Is it a function or an object? Strangely, it's a function. But that's because, the function makes functions. So we know this is a function, not an object, but all function, not a plain object, right? But all functions are themselves also objects. So this is again here a function object combo. So I just wanted to point out that technicality. Again, I barely have a grasp on that. I'm not sure that everyone really needs to, but I just wanted to point it out for completeness sake. Yet another oversight. I wanted to show one last thing that my example 4 drawing is overlooking. You can see that on this drawing I've corrected the properties here on R. But each of these 3 functions here, array, object, and function, they're prototype properties, each refer to an object, right? They are objects, and all objects also have a constructor property. I'm not showing that constructor property on any of those 3, but just to let you know, the constructor property on each of those 3 just refer back to the functions themselves, as you can see here, right? So if array, then get the prototype property. Okay, we got this object here. Okay, now the constructor property that should be sitting here that I neglected to write in here. What does that refer to? Well, it just refers to array itself, and the same thing for function here, and the same thing for object here. Okay, now we're going to actually look at some object-oriented code that we could write. This is example 5. This is a way of writing object-oriented code in JavaScript. It's not the most recent ways, but it is a way. And what we're going to be doing here is we have an object that has a bunch of functionality that we're going to want to share with other objects that we create. And down here we have a function called user creator. And what this is going to do is it's going to spit out different objects different new users. And each user, we're going to set up an ability to inherit from all the different functionality, all the methods that are in here. That way, rather than create a bunch of different user objects that each have copies of all the different methods, right, and really repetitive, they'll just be there'll be a bunch of different individual users, and each of those user objects will be able to inherit from this object, which will have all that shared functionality. So let's take a look at what's happening here. On this line, we're going to call our function user creator and pass in a couple arguments, Ryan and 3, and those get assigned to the parameters name and points, right? And the return value of calling this function is going to be assigned to this variable user. Okay. Within the function here, what we do is we initialize a new variable, and it's going to reference the result of this. So what we're doing here is we're calling object.create, right? We're invoking the create method on object. Now, I'm not going to keep going back to this, but just for a trip down memory lane, how are we able to get create? How are we able to reference that property and invoke its value as a function here? Well, we know that, let's see here. So we're trying to reference a create property on object. Okay, create actually is right in object. It doesn't have to, JavaScript doesn't have to look anywhere else for it. Let's see. So if I'm in a console, object create, we can see it is there, right? And if I were to, if the create property wasn't there, we remember that objects under proto, like if it wasn't in here, if create wasn't down here, its under proto property would refer to the prototype property on function, and that's where it would go looking for something. But it does find it there, and we can sorry, just to double check, right? Because I said that, if it hadn't found create here, well, where would it look? Well, it would look at its under proto, which would be function.prototype, this object here, right? And function.prototype we can look into and say, is create there? No, it's not. It is actually just directly an object there. Okay, so that's pretty cool, but we don't need to keep rehashing that. From now on, let's just take it for granted that we have the general idea of how JavaScript is going to get us all that built-in functionality that we need. Okay, let's talk about what that function does. So object.create, what this does is it creates a new empty object, and it sets the dunder proto property of that newly created object automatically for us to something, and it sets it to the object that we pass in, user function here. So as of right now, pretend there's nothing else in this user object. It sets its dunder proto to the object that we passed in, user functions, up here. Okay, then what are we doing? Now we have this new empty object. It's already got its dunder proto set up to here to user functions. Okay, now we reference that empty object because it's saved, right, in new user. That's what happened here. The return value of this got saved into this variable here. So this variable now references that new empty object on the heap. Okay, so now we set a property of name to name and a property of points to points, right? These parameters hold those arguments that we passed in. And then now we explicitly, and this will become important later, we explicitly have to return out that object that's represented by new user. Okay, so that's the return value of this, of calling user creator, and now our variable user holds that. Let's take a look at what's going on now in the diagram. So this is our user object. It has a property called name that refers to a string Ryan, a property points that refers to 3. It's Dunder Proto, as we said, was automatically set for us. That's what the functionality here, object.create, that's how it's implemented. That's what it does by JavaScript. So Dunder Proto points to user functions now. And the constructor of user, note, is object. Okay. And now if we're looking at the user functions, right, user functions is just a plain old object now. It is not a, this is not a function. So this is not a function, we're not looking at a function. We're not looking at the object form of a function here. We're looking at a plain old function, right? Its Dunder Proto will refer to the prototype property and object, and its constructor is also object because it's a plain old function, remember. So let's talk about that for a second. So here's the code that just double checks, what I just laid out in the diagram. Okay. Let's refer back to that confusion with prototype and Dunder Proto and stuff. So is there a prototype property on either of these two objects? No, there's not. There's only a prototype property given to us on functions. That's the only time. So when we're looking at the object, form of a function, that's when you'll see that prototype property that's automatically given to you by JavaScript. So we don't have it here. Right. Yet we still refer to, what's the prototype of user? In common parlance, what would you say the prototype of user is? Well, the prototype is the thing that its Dunder Proto refers to. It refers to user functions. So the prototype of user is user functions. Yet, we don't see any prototype property here. So you start to see why, having those naming choices, that language is a bit confusing. And that's part of the source of the confusion. So, okay, now if we were to actually, run some code here, we were to invoke the method add on user, what happens? Well, add's not a property on user. All JavaScript sees is name and points, right? So what does it do? It keeps looking for name, it keeps looking for add. We're trying to find the add property. It doesn't find it, so it looks in its Dunder Proto, which refers to this object over here, user functions. It goes looking, it does have add, right? The add property refers to a function, okay? And then we are invoking that referenced value, that function, right? And now take note that this is the function we're invoking that we found, okay, add. Take note that it's implemented using the this keyword, and I assume everyone knows how the this keyword works. This is method invocation, right? So this is going to refer to the calling object in this case. So it's going to invoke that method or this function in the context of the calling object user. So this refers to user here, right? So the points property on user is here, which refers to 3, right? And what we're doing is we're incrementing it by 1. So that should mutate our objects. So now points should be 4. Okay, so I think that concludes example 5. I think it's a lot easier to understand now that we kind of went through all that hard work of understanding how JavaScript itself works. This is kind of child's play in comparison to example 4. So yeah, let's keep moving on. Look at example 6 here. I want to step back for a second and say that my goal in this video series is not to explain everything in object-oriented JavaScript. There's too much there. It's not to go through all the pluses and minuses of the different syntaxes and different approaches in creating objects in JavaScript. There's other places, you can get that, namely Launch School. There, my goal is really to just help showcase like a visual way of looking at inheritance here and how it all works, and then hopefully you can put that together with the other pieces you already have, and this can be like a really nice mental model for visually understanding what's going on. Okay, so anyways, example 6, rather than use a top level object that all other objects that we create are going to inherit from, here we're going to have a function, user creator, that's going to help us out. Now this is known as a constructor function, and we capitalize it just out of convention to let developers know that you need to call this with the new keyword. The new keyword provides a execution context. So when we call user creator here, new does some things for us. Now, if you don't use the new keyword, there can be some negative effects. You'll clobber the global object, and I'll explain what I mean in a second by that. Okay, so on this line, what are we really doing? You wouldn't say, well, we're creating a new user creator. That's not really the right way to think about it. What we're really doing is we're just calling user creator, and we're passing in Ryan and 3 as arguments, right? But we're doing so with the new keyword, which provides a new execution context for that function. Okay, and then we're going to save that result to the variable user, right? So user's going to refer to that return value. So what does new do for us? It does some things automatically that we had to do explicitly before. So we pass in Ryan and 3 as arguments. The parameters name and points now refer to those arguments, right? Those are local variables now here in user creator function. Okay, new, the first thing it does is in this new execution context for user creator function, it creates an empty object for us. Okay, before, remember, we had to use object.create to get that new empty object. Okay, new does this automatically for us. Okay, then it assigns the keyword this to refer to that newly created empty object. Before, we had to constantly refer to the object that we created and then put the properties and then add new properties to that object. Okay, now this refers to this empty object for us. And then it sets automatically, this is what new does for us, it sets the dunder proto property of that newly created empty object to the function's prototype property, to user creator's prototype property. Okay, that's really important. I said that before in the earlier videos, right? That is going to be the place now where we get to store all of our functionality. In the last example, we had an object at the top where we stored it all. Now we're using a function. Like, where are we going to store all of our methods, all of our functions that we want our objects to be able to invoke as methods? How are we going to do that? Well, remember, function, user creator here, all functions are objects, right? And all object forms of functions give you that prototype property, right? Not regular old objects, but functions do. They all have a prototype property, which itself refers to an object. And that is where the new keyword comes in. When it gives us this new empty object, right? And it sets this to point to it. It also sets the dunder proto of that empty object to the property prototype on user creator. Okay, I have a visual diagram. I'll explain this visually in a second here. And then the last thing that the new keyword does for us is it returns out that empty object for us automatically. Before, we had to return it out explicitly. Okay, so let's take a look at this diagram. This is example 6. So we said that the new keyword gave us that empty object, right? It set the dunder proto automatically for us to the prototype property on user creator, on that function. Okay. The constructor property is user creator. Remember that refers to the function from which this object came. Okay, this is the function user creator. This is the function that created this empty object. So the constructor points to it. Right, and then let's look at the next line of code real quick. Here, what are we doing here? Well, now we're going about and adding that functionality that we want all of our objects to be able to inherit from. And we're putting it where? We're referencing user creator, that function. We're referencing the prototype property on it. And then we're going to create a new property, add there, that refers to this function. So that's what we're doing here, right? We're referencing user creator, referencing that prototype property itself, which refers to an object, right? And then we're saying, hey, we want the add property on that object to refer to this function here. And that's what it does. Okay, so let's go through, before we actually run a bit of code to see how this would work, let's do a couple confusion checks. So what does the dunderproto property on user refer to? The dunderproto property on user refers to the prototype property on user creator, right? New did that for us automatically. This little object right here. Okay. Let's actually move that over a little easier. And then what is the dunderproto property? So does the dunderproto property on user, does that refer to user creator itself? No, it doesn't. That's the constructor property refers to user creator itself. The dunderproto property refers to the prototype property on user creator. Okay. So in common parlance, what would we say when we say that, hey, what's the prototype of user? You might catch some people thinking that, well, the prototype of user is user creator. Well, it's not really. The prototype of user is the prototype property on user creator. It's an important distinction. Okay. So now this is also important to keep in mind. Another confusion check here. And we just run this code. You can verify that is all, in fact, the case. So our next confusion check. Where is JavaScript going to keep looking up the prototypal chain here, right? So if we try and call something on user, if we try and invoke a method on user, where is it going to keep looking? Well, we know that it looks at its dunderproto, which points to the prototype property on user creator, and that's where it's going to look for something. But what if it couldn't find it there? Where would we then look? Well, this object itself, it is an object and it has a dunderproto property, and it refers, remember, to the prototype property on object. Okay, now here's just the point of confusion I want to make sure we all understand. User creator itself, that's a function, but all functions are objects. So in its objects form, you better believe it has a dunderproto property. That points to function.prototype, the prototype property on that thing called function. Remember, we looked at from example 4. Okay, that is not where JavaScript goes and looks for things it can't find here in user. Okay, that would be if you tried to call a method on user creator itself and you tried to reference a property here that it couldn't find. Then it would go looking in its dunderproto here and go to function.prototype. It's an important distinction. Try not to get confused there when you're thinking about this visually. These things are both objects, so they're both going to have their own dunderprotos. But you got to keep in mind where you're coming from. Here from user, right? If we can't find a property here, JavaScript looks in its dunderproto, which goes to here, the prototype property and user creator. That it'll start looking here in this object and go down the list. No, can't find it. Okay, then it looks in the dunderproto of that object. Okay, which points up to the prototype property on object here. So just a little distinction there that would sometimes trip me up when I was trying to actually make this video. And I just had to make sure that I was, putting everything in the right place. So now let's actually get back to our code here. If we invoke the method add on user, well, what happens? Okay, let's take a look. We try and find a property add within user, and we want to invoke the value that it refers to, and we're expecting it to be a function. Okay, it has name, Ryan, points, 3. I don't see any add here. So JavaScript looks at its under proto, comes over here to the prototype property of user creator, starts looking. It finds a property named add. It invokes the value that add refers to. That's this function, right? We can see over here that the add function is this thing right here. Oops, I shouldn't have clicked. And it's invoked, or it's implemented using the this keyword. We know that when we use method invocation here, the this keyword refers to the calling object. So this in this instance is user, right? So this here refers to user, this object. So we reference the points property on it, which is 3, right? We go about incrementing it. And so when we come back here and we try to console.log and refer to user, the points property again on user, we find that it has changed to 4. Cool. So that's example 6. And I think that, you may be starting to find this to be much easier to understand now that we kind of did all that hard work at looking at how JavaScript provides us its functionality. All right, let's move on. Okay, we're going to look at example 7 now. This will be an example of how to create subclasses with the same sort of setup from the last example that we had. Now I could have done a subclassing example from example 5 here, where we had an object that all of our users were going to inherit functionality from, right? And then we could have had a subtype of user that would have inherited from functionality from the regular users. But there's really just too much to go over, and remember, my intent's not to go over everything. It's once you have this visual mental model down, you can look at any syntax and you'll be able to figure it out. So now we're going to look at subclassing here, and the idea is that we're not just going to create users that have some functionality. We're going to create some subtypes, like some subtypes of users. So maybe a paid user that's able to access all the functionality that a regular user would have, plus its own unique kind of behavior that it can exhibit. So let's look at what's happening here as a basic setup. I know there's a lot of code here. Most of this is just kind of sanity check type code. We'll get there, but right now just focus on this. So we're going to create a regular old user, right? So we're going to call the function user creator here. We're going to pass in an argument of Dean. Okay, the parameter name's going to be assigned that value. And remember what new does. It gives us a new execution context. So now new is going to be, it's going to create a new empty object. It's going to assign this to that empty object. It's going to make the Dunder proto property within that empty object refer to the prototype property on user creator here, right? This code's going to run. So this is that empty object, right? So we're going to put a name property on it. That name property is going to reference the value held by our parameter name, which was Dean. Okay, and new is going to automatically return out that object for us. So now user 1 is holding that object. Let's just take a quick look at it. Try not to look at all this yet, okay? User 1 here. Name property, Dean. Okay, we did that via this line right here, right? It's Dunder Proto property. We know that new automatically made that reference the prototype property on user creator. So user creator, it's prototype property. New did that for us. Okay. The constructor property refers to the function that created this object. So user creator. All good so far. Let's look at creating a paid user now. So same thing. We call the function paid user creator. We pass in two arguments, Ryan and 3. So the parameters paid name and balance will take those values. We are calling it with new, right? So that's that new execution context that it gives us. So it creates a new empty object, and it sets this to refer to that empty object. So here what we're doing is we're going to now call user creator from paid user creator, right? And we're going to call it using the call keyword, or call, sorry, not call keyword, the call method. We're going to invoke the method call on user creator, right? And we're going to pass in two things. And you know what call allows us to do? It allows us to pass in a context. So we're going to pass in that empty object, right, that this refers to. We know that because we called this paid user creator with new. It gave us that empty object, set this to refer to it. So we're going to pass in that empty object. And we're also going to pass in paid name. Okay. So now what happens is up here, this refers to that empty object. And we put the property name equal to the parameter name, which refers to, right, the argument we passed in, paid name, which held Dean, or sorry, which held Ryan. So name in the empty object now refers to Ryan. And notice, nothing gets returned out here. There's no return value, but we don't need a return value. What we did is we passed in that empty object that this referred to here, and some code ran and it mutated it. It put a name property on it, and it set it equal to the argument we passed in, Ryan. So there was nothing to return out. That empty object now, after this line of code runs, well, now our object's not empty anymore. It has a property of name with Ryan in it. Okay, and then now this still refers to that object. We put a property of balance on it, and we set it equal to the value held by the parameter balance, which is the value 3 that we passed in as an argument. Okay, bit of a mouthful. Let's look at it. Here's that paid. Don't look at anything else yet. So here's paid user 1, right? It's that object. Remember that because we called it with new, it got returned out automatically and set to paid user 1. Right? Property name is Ryan, balance is 3. The other thing that the new keyword did for us is set the Dunder Proto equal to paid user creators prototype property here. Okay, so now where we stand is, as of right now, we have this user 1 object, this paid user 1 objects. Their Dunder Protos point to the respective correct places. This paid user's Dunder Proto behavior for paid users, user 1 is going to inherit from paid user creators prototype property. That's what we want. Same thing for the user 1. Okay. But now the question is, we want our paid users to be able to have an inherit functionality that all the users have. We want the regular users to not have access to that. They're just going to inherit behavior from, they're just going to have their own behavior. So the question is, how do we connect up the inheritance chain from here, the prototype property on paid user creator, this object? How do we make its Dunder Proto point to the prototype property and user creator, so that, if we try to invoke a method on paid user 1 here, and JavaScript can't find it, so it looks up the chain to the prototype property and paid user creator, and it can't find it here. Well, we want it to now, we want this Dunder Proto property to point up here. as of right now, where does that point? Well, let's take a look. So if we weren't to do anything else, paid user creators.prototype property and the dunder proto property within that object itself, stay with me, is right here. That's where we're at right now. So we're asking, okay, where does this dunder proto point to? Does it point to object.prototype? Yeah, it does. That's where it points to, just naturally. It doesn't point to user creator prototype. It doesn't point to where we want it to. So we need to somehow fix that. Okay, so here's what we can do to fix that. We say, okay, we want the prototype property on paid user creator to point to this, the result of doing this. And what we're doing here is we're saying, okay, object.create, we want to create a new object. Remember what object create does. It creates a new empty object and it sets its dunder proto to the thing that you pass in, the object that you pass in. And here we're passing in user creator.prototype. Okay, so we're passing in the prototype property of user creator. Here's user creator, here's a prototype property. Okay, it refers to this object. So that's the object we're passing in. Okay, so we want to create a new empty object. That's what object.create does. And it automatically, remember what else it does, it automatically sets that new empty object's dunder proto to point to the thing we pass in, which is this thing. So what we're doing here is we're saying, okay, paid user creators.prototype, this thing right here, this object, instead of what we had before, which was an empty object whose dunder proto pointed up to object.prototype, let's replace that whole thing. It goes out the window. This is, reassignment. We're not mutating anything. We're tossing the original one out the window, and we're saying replace it with this other thing, this new object, okay, whose dunder proto points up here. That's how we've now fixed the chain. The problem is, one other thing you need to do is you need to fix the constructor property on it. I just was realizing that I was about to neglect to discuss something, and I'm sorry I don't have it on my diagram here. But before we swap out this object, which I'll review in a second, what does the constructor property on this object here point to, right? So if we were to say paid user creator, reference that prototype, reference that object, reference the constructor property on that object, what does it point to, by default here? It's pointing to paid user creator right here. That's where that constructor property would point to, right there. Double check that. Okay, cool. Now, remember, in order to get our prototypal chain the way we'd like it, where we have JavaScript looking for properties it can't find here up in the prototype property on user creator, we swap out this whole object, right? We replace it with a new one via this line of code here, which I already discussed. Okay, but in the process, because that's a whole new object now, the constructor property is a new one, right? The old constructor property is gone. That whole old object's gone. So we just clobbered that thing. So we need to fix it and put that constructor property back to paid user creator, right? What does it point to right now after this line of code, after we swap out? It would point to, well, we can see that it doesn't point to paid user creator as it originally did, right? That's false. It doesn't point there. It points to user creator. That's where its constructor now points to, which is not really what we want, because we might want to use a constructor property later. Again, yeah, I hesitate to get into everything because I can't really. But so we're going to fix that constructor property. So now we say, okay, paid user creator, get that prototype property, get the thing it refers to, this object, right? Get the constructor property and set it back to paid user creator. Okay, all is right in the world now. Now we've completed our prototypal chain, but in doing so, we clobbered the constructor property here. that was on the old object that used to be here. Okay, now we've reset the constructor property back to pointing to paid user creator. Okay, so I think a couple more maybe sanity checks of code here. Let's see what I'm trying to show here. Paid user creator, we reference the prototype property on it, reference the Dunder proto. So paid user creator, reference the prototype property, reference the Dunder proto. Right. Okay, so I'm just demonstrating that we actually have fixed the prototypal chain here, right? Where does Dunder proto point to here now? It doesn't point to object .prototype as it originally would have, right? We swapped out this whole object and we did it with object.create, and which set the Dunder proto to the thing we passed in, which was the user creator prototype, this thing right here. So this is false, this is true, all is right in the world there. So, right. So just a sanity check here. Does the prototype property on paid user creator, this thing right here, this object, is it the same thing as the prototype property on user creator? In other words, is this object the same as this object in memory? No, definitely not. They're definitely different objects. This one's Dunder proto allows us to inherit, from this object, but they're definitely different objects in memory. And that's super important because they hold different things. This one holds object or functionality that we want our paid users to have access to. And if it's not there, well, then it can go look up and find the functionality in user creator, right? And this one holds functionality only for our regular users, right? So sometimes, well, I guess you might see this, but the wrong way to try and make this connection would have been to just say, hey, let's just make that prototype property and paid user creator the exact same object as the prototype property and user creator. Let's just have them refer to the exact same object in memory. And that would be bad, right? Because then there'd be no difference between our users and our paid users. Anytime you tried to add functionality for your paid user creator and mutate this object here, well, you'd be mutating the exact same object that this prototype property would be referring to. And so all your users, all your regular users would get functionality that's only referred to the subtype, the subclass paid users. So that would be bad. So just a point of distinction. Right. So another way to fix this prototypal chain versus the way we did it, which was, replacing this entire object, we could have said, okay, let's reference the prototype property and paid user creator, this object. Let's reference its Dunder proto, and let's just change what that points to. Let's make that refer to the prototype property and user creator. Okay, so we're just changing where this property refers to. Now that property is going to refer here. So that would have been, and this would have worked perfectly fine. Like, it would have totally fixed our prototypal chain. And by doing it that way, since we didn't swap out this entire object, right? We just changed the reference that this property has to point up here, right? We didn't change anything else about it, so we didn't clobber that constructor property. So there'd be no constructor property reference to fix here. We would have been all good. However, I'm no expert on this, but the documentation does warn that changing the prototype property, the Dunder proto property like this is not a good idea for performance reasons. You can check this out more on your own here. So it does recommend in such a situation that you, for performance reasons, you'd be better off creating a whole new object as we did. Okay, just a point of note there. Okay, what do we do next here? We add some... let's walk back up. let's walk back up and put some functionality in those actual prototype properties. So for our regular users, we're going to reference the prototype property. Oops. We're going to reference prototype on user creator here, and we're going to create a new property, say name, and it's going to refer to a function. This code right here. Okay, fine. And then down here, what we're also doing is referencing the prototype property on paid user creator here, right? And we're going to put in a function here. We're going to have this property increase refer to this function here. Okay, so now we have some functionality that users can get access to. We have some functionality that paid users can get access to. And so let's see what else I have to explain here. Right? The Dunder proto of user one does in fact point to user creator prototype, right? We know that. And the Dunder proto here of paid user does in fact point to the prototype property and paid user creator. Correct. So now that our prototype, I can just run that, I guess. True. So now that we have our prototypal chain set up correctly, our paid users are going to get access to the functionality that users have, but not the other way around. So if we tried to call some functionality intended for paid users, that's in the prototype property here on paid user creator. If we tried to call increase on a regular old user, this user one here, right? We tried to invoke the method increase. Well, what would happen? JavaScript would look in user one, it would look for a property named increase, and it would, if it found a value that property referred to, it would invoke it, expecting it to be a function, right? But let's first try and find that property, increase. There's nothing here, it's just name, so JavaScript looks in the Dunder proto property, which refers up to the prototype property on user creator, and it sees say name, but it doesn't see anything else here. And now I'm not going to go through the rest of where this looks. You know that this is going to look in its Dunder proto and then go up to object.prototype, right? So in this instance, you notice we're skipping this prototype over here, right? It's not in the chain for regular users, okay? It goes here, and then it goes up to object.prototype. It's not going to find it there either, right? So increase is going to be undefined. And then when we try and invoke undefined as a function, you get a type error because undefined is not a function. You can't invoke it as one. Okay, so let's actually try some code that works. We're going to try and invoke the method increase on paid user one now. Okay, so we look for increase. I see name, I see balance. I don't see any increase, so JavaScript looks in its Dunder proto, goes up to the prototype property on paid user creator, and it finds a property named increase. That property refers to a function here, refers to this bit of code, this function, right? We invoke it. Remember what the this keyword does. Since this was method invocation, this refers to the calling object, so paid user one. Okay, so this is this object here. We refer to the balance property on it right here. We increment it by 1, so we mutate it. This object, it will now be 4, right? Balance will be 4. So if we now log out paid user one's balance, we should see 4, and we do. I also have us calling the same name method here, I guess. So, right, we should walk through that, I suppose. So, same process. We try and find a say name property here on paid user one. We can't find it. We look in Dunder proto here. We see increase. We don't see say name. Because say name's not functionality that's specific to paid users. It's more broad, general functionality intended for all users. But since we have our prototypal chain all correctly set up, JavaScript's going to look in this Dunder proto, see where it points. It points up to the prototype property and user creator. There's say name. So we run the function here, right? But we look at what that function looks like, right? This is the function say name, right? So it utilizes the this keyword. This refers to the calling object, so it's going to log out I'm, and then this refers to paid user, right? So this dot name is Ryan. I'm Ryan. All right. So I think that concludes example 7. Okay, this is example 8. This is actually the last example I'm going to go through. This is a newer syntax that JavaScript gives us to create object-oriented code. This code's much easier to write. We have to do a lot less explicitly, but the trade-off for that is that JavaScript hides a lot of what it's actually doing behind the scenes from us. The good news is that what it's doing behind the scenes, the end result of that is exactly the same thing that we just looked at. It's the same thing. There's a couple little magic bits maybe about the particular nature in which it implements it, goes about it via some of these keywords, but it's basically the same thing. And I'm going to do, I guess quite a bit of hand waving during this example because I don't know myself exactly how a couple, super precisely exactly how the implementation is for a couple of these things. But I do know that at the end of the day, it is essentially the exact same thing we just looked at. So first of all, what's really different here? We have this new class syntax. Okay. That class keyword is interesting, right? But let's just have a quick sanity check. What are those things? Like, what is user creator here and what is paid user creator? They're still just functions. And remember, all functions are just objects in JavaScript, so they have that object form. Okay. The constructor keyword here within this class, what is that? That's just like a subtitle for this function here from the last example. So it's doing the exact same thing that this function's doing right here. Okay. What else is going on? We have say name here. Notice the interesting syntax in here, right? There's no need to have like a function keyword or something like that. What the class keyword does for us is it automatically just puts any functionality you list down here within the class in the same place. That's the thing that's staying the same here that I think is important to recognize. It's just automatically doing it for us. We don't have to, like up here in this example, we don't have to reference that prototype property on the function and then, add a property and then put some functionality that property refers to. JavaScript's just automatically taking this functionality and it's putting it in the prototype property for us. Okay, so let's look at user 1 when we create a user here. So we're going to call user creator, right? We're going to call that function, pass in Dean. The new keyword still gives us that new execution context. So we have that new object. We said the constructor is really just a subtitle for this function here. So we're basically just taking that object, right, which is referred to by this, putting a name property on it, setting it equal to the value we pass in Ryan. Same thing as before, right? And I said that JavaScript automatically puts this bit of functionality in the prototype property of the function user creator. Okay, so let's look at what's happening here with paid user 1. When we call paid user creator and pass in Ryan and 3, and we use the new keyword, so we create a new execution context. Class keyword is doing the same things for us up here or down here that it did for us up here, right? Increases automatically going into the prototype property of paid user creator. The other thing we have here is this keyword extends. Well, what does that do for us? Well, one thing it does for us is it sets the Dunder proto of user creator.prototype automatically for us. Remember before, it sets it automatically to the prototype property of user creator, right? That's how we want things to look, right? We want this Dunder proto in here to go up to user creator's prototype property here. And remember, we had to do that manually before. We had to swap out this entire object, right? Well, that just happens now automatically for us via the extends keyword, right? Super is also a new keyword. That I can pull up the docs here. You can look into more of this yourself, but it allows us to call the parent constructor. Okay, so that's going to call this function up here, right? So we're going to do the same thing. We're passing in paid name, so we're passing in Ryan, right? So now it's going to get a name property. That object's going to get a name property on it, and its value will be Ryan. It was explained to me that there is a slight difference. Remember before where when we were doing this, and we were calling right here. We're calling user creator from paid user creator, and we were passing in that empty object that we had gotten from the new keyword that this referred to now, right? So there was like a mutation effect, right? That we were mutating that object, that context that we passed in. Apparently, the empty object is not, this apparently in this situation is set to, it's uninitialized. And apparently the empty object's born in user creator instead. But at the end of the day, and I think you can, there's some places in the documentation you can look at to try and suss this out. I was told that reflect.construct is one to help figure this out. But at the end of the day, whether it's born here, born there, I'm not sure it matters so much, right? We're still able to put a name property on that object, even if it's born here, fine. And then it's returned here, okay, fine. We have the object, we have a name property on it. It refers to the value that we passed in as an argument, paid name, which was Ryan, fine. And then now we take that object and we reference the balance, we create a balance property on it, set that equal to refer to the parameter, the value held by the parameter balance, which was, the argument 3 that we passed in. Right, so at the end of the day, it's really the same thing. And we are left with this setup. Sorry, I had to do another take because I started tripping over my words right there. So I was told that the other thing that extends, the keyword extends, does for us is that it changes the Dunder proto property on paid user creator itself here, which normally would refer to function .prototype, the prototype property on function. That's what it would normally refer to, but extends changes that and it sets it to user creator. So we can check that right here. Paid user creator, we reference paid user creator, reference that Dunder proto that would be right here. What does that point to? It points to user creator now. Again, not important, I guess, but apparently that's what allows us to call super like this in the the way that JavaScript implements it under the hood. At the end of the day, I don't have a great grasp on it, but apparently that's what allows that to happen. So let's look at what our current situation is, though. So we have user 1, right? We created it. What does its Dunder proto point to, and what is its constructor? Well, its Dunder proto points to the prototype property on user creator. User creator, prototype, that's where it points to. Its constructor is user creator. Now, notice I just crossed out example 7 and said, okay, this is example 8. Like I mentioned, there's a couple little magical bits about how JavaScript recreates, this, but the takeaway is that it basically does the exact same thing under the hood, and the end result's the same, and you have to do less of it explicitly. It just kind of hides even more of it from us. Okay, so let's look at paid user 1. It's under proto points to paid user creator.prototype. So paid user 1, it's under proto points to the prototype property on paid user creator. Yep, that's exactly where we want our paid users to get their functionality from, right? And then paid user 1's constructor, does that point to paid user creator? Yes, it does. Constructor points to paid user creator. Great. Now, making sure that the rest of our chain is intact, the paid user creator prototype, and then the proto on it. So paid user creator prototype, which is this object here. The proto on it, where does it refer to? Well, we want it to go up there to the prototype property on user creator. It in fact does, right? And where does the under proto on the prototype of user creator go? Well, that goes to the top of the chain, the prototype property and object. True and true. Okay, great. So if we were to try and invoke the method increase on paid user here, what would happen? JavaScript looks here. It does not find any increase property name. It looks at it's under proto. We go up to, which points to the prototype property on the paid user creator function. It does find increase. It finds an increase property by that name, right? Which refers to a function over here, right? Which is this function, right? Which is implemented using this keyword, which refers when you use method invocation like we are here, this keyword will refer to the calling object. So the balance of the paid user here, right? Which is 3. Functionality here increments that value, right? So we should see now that we have 4, which we do. And then now one more run all the way up the chain. We try and invoke the method sayName on paid user 1. Can't find it, looks in Dunner Proto. Can't find it here, looks in its Dunner Proto, which points up to the prototype property on user creator function. There's same name. Okay, we invoke the value that same name property refers to, right? That functionality is here again. It will log I'm, and then it will interpolate the name property on whatever this refers to. Well, since it was method invocation, this refers to paid user. So the name property on paid user refers to Ryan. So we get I'm Ryan. So yeah, that concludes this entire video. I hope this is helpful for you. This was super helpful for me. Even making this video cleared up some things for me. Cleared up a lot of things actually. I'm still a bit hand wavy on, as you could tell, on some of the exact details of how JavaScript is doing a couple of these things in here, but I know that under the hood, really the end result is we get here, which is exactly what we had before. So I think that's the most important part to understand. I won't pretend, right? I'm not trying to like pawn off this way of looking at things, and some of the terminology I used is my own. I didn't come up with these things. I got these from other places. I learned this from other people. As you're going through your journey of learning object-oriented programming, I recommend that you go straight to the experts, right? Paid resources wherever you can find them and look those up. But I wanted to create this video to help me with my own mental model and maybe help show other people a way to visualize all of the stuff that's happening. And I think once you have that visual mental model of what's happening, no matter what syntax you're looking at that's being used, you'll be able to actually understand what's happening under the hood. Thank you.